This video covers assignment 17-7. So we're going to start by solving these inequalities and graphing them on the grid to the right. So when we solve, remember we're getting y by itself. We move x to the other side and then divide by the number in front of y. To graph this one, we're going to start at -8. Sorry. That's a 5. We're going to start at -8. 1, 2, 3, 4, 5, 6, 7, 8. This line is going to be a solid line. Remember, the line under the inequality tells you it's solid. If there is no line, it's dashed. And then y is less than or equal to -8. Less than goes lower. So once we've drawn our slope, we're going to go lower or underneath our y-intercept. So my slope is -5, which means down 5, right 1. I can't do that from here, so I'm going to go up 5, left 1. Just a couple of times. And then again, this is a solid line. So we'll just put a 1 for equation 1. And then it is lower than my y-intercept, so underneath the y-intercept. For the second one, to solve for y, we finish off by dividing everything by -3. Because we divided by a -3, we are going to switch this inequality symbol to go the other direction. Remember, if you divide by a negative, you flip your inequality symbol. So this one's going to start up at 2. We're going to go up 1, right 3, up 1, right 3. This line will be dashed because there is not a line under the inequality. And then y is less than 2 will also go lower. So lower than 2 would be underneath. So we're going to shade everything down here. This is our second line. And then our third line is a special case. I know it's special because I only see one letter. So I go to y equals -8. This one will be dashed. So here's -8. And this will be a dashed line. And then y is less will go lower. So we'll go underneath that line. And that's our third line. Okay, and then the only other thing we're going to do is review quadratic transformations. So what do the changes do to the graph of x squared? I do want to remind you that you can use this knowledge. You can also plug these into y equals. So you can plug x squared into y1, whatever your changed version is to y2, and just see what changes are happening. But vertically, if k is positive, so if we're adding to the back, and these letters are coming from this transformation form up here. So if we add to the back, it's going to go up. If k is negative, so we subtract, it will move down. If the parentheses has an x minus h, we're going to go to the right. Remember, parentheses lie to you, so whoever's hanging out with your x is lying to you. So if we see a negative, it's actually going to be the opposite of what we think. And then if we see a positive, normally positives go to the right, but our parentheses are hanging out with our x's, and our x's are liars. If a is greater than 1, the graph stretches vertically. And if it is between 0 and 1, it compresses. Remember, we talked about your height. So if you're twice your height but your same size, you're going to be really stretched and skinny. If you're half your height but your same weight, you're going to be really smushed down. And then if a is a negative, the graph will reflect across the x-axis. And then horizontal, remember, are the opposites. So if a is greater than 1, it stretches. If it's horizontally greater than 1, it's going to compress. And then if b is between 0 and 1, it will stretch. So these are opposites of a. And then if you're given something in vertex form, the vertex can be found at hk where h is the opposite. So whatever you see here, like this is a negative h, so the vertex is the opposite, so positive h, comma k. Okay, so I want to remind you, for these, like on these examples, 18x squared and 18x, you could plug that into y1 and y2 and see if what is being asked of you is happening. So remember, you can use a calculator. Just because we didn't on the review does not mean that you can't use it. So don't be afraid to use those calculators as needed.